So now in this video, we're going to look at series capacitors. So you want your series capacitors to be equal value. We're going to use 1000 microfarad here. If you have unequal values, you really got to know what you're doing. So there's a couple of things. First off, as long as they're equal value, which they should be, you're going to have a fractional amount of capacitance. And so it's going to be half if there's two of them in series. If there's three of them in series, it'll be a third of the value of one of them. Now the other thing with series capacitors, one of the benefits that you will learn about when you learn about capacitors in series is that the capacitor can have a higher voltage applied to it when they are in series, and this is why. So let's say each one of these capacitors is only rated for 5 volts. As long as everything is perfectly balanced, you can take a 10 volt power supply to charge them, and each one of them will have 5 volts right there. In fact, that's why the capacitance is less. For every little bit of current that goes into one capacitor, there's also that much current going into the other capacitor. So they're both charging at the same time with the same current. And but then when they discharge, each one of them has to discharge a little bit of current, and so there's not as much current flow for a rapid voltage change. And here we are on the board. So you can see 1000 microfarad on the two of them. That's the rated value. Their actual value can actually be off quite a bit. Capacitors are not completely accurate with their rated value. But in case you can see, we got the positive side of that one. They're polarized to the positive rail. The negative side there to this row. And then the positive side of this one, because that's towards the more positive side of the circuit, to where the negative of that one is, and then negative to ground there. It's pretty straightforward. We're going to set the meter to measure voltage. This is an auto ranging meter. I just have one setting for voltage, and I can leave the red probe in that same spot unless I'm measuring high current. So I really like this meter, but they don't seem to sell it anywhere anymore. Now I'll hit the power supply power button, which turns the output on. You may have saw that we hit the current limit of 20 milliamps just for a brief period of time. That's because these are somewhat high value capacitors. They need a little bit more than 20 milliamps of current for just a brief period of time, but now they're fully charged. They don't need any more current. So if you need an instant charge, you'd have to set the power supply to measure more current. But that's topics for other videos. Let's measure the total voltage right there. And you can see it's just shy of 10 volts. Looks like we're losing a little bit of voltage along the way for whatever reason. Now we're going to go across this capacitor, and again, it's shy of 5 volts. But it is not, it's more shy of 5 volts than we had before. So I bet this capacitor actually charged to a little bit more than 5 volts. And as you can see right there, so they're not completely balanced. Something's going on where one got slightly more charge than the other, but they're still really close to each other. So that's something to be aware of. Even if you're careful, they can be slightly unbalanced or worse. So now before we measure capacitance, we want to turn the power off. Hopefully that discharges them, but just in case, what we're going to do is take them and put them directly to the same power rail right there. And if they're extremely high voltage, that'll be a big spark. And higher value capacitors, there'd be a big spark if there was charge across them. So only do this with lower value capacitors that probably don't have much voltage across them. Otherwise, you could use a resistor to discharge them a little bit more slowly, but a lot more safely. Setting the meter to measure capacitance, really easy. We got a capacitor symbol there. For this particular one, don't have to move the red probe for anything than high current, as I said before. And the meter still is polarized. We put the black probe to the negative side, the red probe to the positive side, and we will get our reading. So now, capacitors are usually not as accurate to their rated value as other components. So we are a little shy of 1000 microfarad, but pretty close, not too bad. Now we'll go to this one, and again, we'll see a little shy of 5000. Main thing, 1000. Main thing for this video is now we put them in series. And so we're still measuring the two of them, but they're in series. We will see that their capacitance goes down in half. It'll be a little shy of 500 right there. And so that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos that I'm posting. Click like, subscribe to the bell. Make sure you turn the multimeter off. If you can donate to Patreon, that'll help out a ton. I will see ya in the next video.